All right, hello. We're going to talk about Newton's 3 laws of motion, and I brought in some stuff here just kind of help demonstrate, just kind of give us an idea of what this topic is, and a simple explanation. We'll try to make this as easy as possible so it's not that hard for you, but to understand these concepts of motion. So the first law of motion is, Newton's first law of motion is called the Law of Inertia. And basically, the simplified version is, things want to keep doing what they're doing. So for example, I have here this rock. And if I just stick this rock on the table, what do you think will happen if I come back? You know, I leave and I come back in about 5,000 years. Guess where this rock is going to be? Yes, still just sitting here. This thing will not move. Right now, there are no forces acting on this rock, and it is just going to stay there. The only way for this thing to move would be to put something in it. The law of inertia is sometimes called the law of laziness because, you know, we don't want to change what we're doing. For example, if I was to ask you right now, if you were sitting in a chair, please stand up, your first reaction is probably going to be, oh man, I don't want to stand up. This is terrible, you know. So that's the law of inertia. So next time your parents tell you to get out of bed, just remember, hey mom, dad, I'm following the laws of inertia. I don't want to change what I'm already doing. Okay? So that's what's going to happen with the law of inertia. All right, the other one is Newton's second law, and it's kind of like an equation. It's basically this idea that the force, the net force, is equal to the mass times the acceleration. All right, that's just an equation. It doesn't kind of mean that much, but basically what it looks like is this right here. You know, I've got here a blue golf ball. I also have this white styrofoam ball, and I have you know, a nice little orange ping pong ball. So basically, I'm going to try to use the same force, but I'm going to hit this white ball and see how far it moves. Okay, it moved pretty good. Now I'm going to try the same experiment, but this time with the golf ball. I'm going to move this one out of the way, and the rock. It barely moved. The force that was needed to move these things, the force was the same, but because the mass was different, they accelerated differently. All right, so the more mass, the less acceleration if you keep this force the same. The less mass, the more the acceleration if you keep the force the same. Now, hope that doesn't break anything. Now the other thing is this idea of the mass is involved in how fast you can accelerate something. Okay. And then we'll edit, because I need to think of what else. We're back. Everything was okay. It didn't get destroyed. Another way you can look at this equation is to look at acceleration, changing the acceleration. If I want to accelerate this ball and this ball, even though they weigh differently, their masses are differently, but I want to accelerate them at the same speed, I have to use a different amount of force. I have to use more force to make this accelerate at the same speed that I accelerate this one. This one takes a lot less force to accelerate. So basically there's a relationship between these three objects: force, mass, and acceleration, and they're all entwined, and we'll do some practice with that more later. The last one is Newton's third law, and probably one of the most famous laws that he has, and it's for every action there's an equal and opposite reaction. I brought in this fire extinguisher. Most of you guys have probably seen the movie WALL-E, and when WALL-E is out in space, one of the ways that he was able to get around is he took one of these fire extinguishers and was able to shoot it. But you'll notice the way he's holding it is just like this. If I'm aiming it this way and I'm shooting the material out this side, I will move the opposite, equal and opposite. So if I'm in space and there's no friction on me, if I shoot this fire extinguisher that way, I will move this way. And if I want to turn around, I got to move it this way and shoot it this way. The same thing could be said in space with no friction. You know, this guy will just move me around wherever I need to go. and you got an equal and opposite reaction. Same thing, if I take my hands and push this way on the wall, my body goes back this way. So there's an equal and opposite reaction, and that is Newton's third law. So just a quick recap. Newton's first law, things want to keep doing what they're doing. Newton's second law is an equation. There's a relationship between force, mass, and acceleration. They're all intertwined, and we can play more with that later. And then the last one is, for every action, there's an equal and opposite reaction.